today. So this is ENS 162, Engineering Mechanics, Dynamics of Rigid Bodies. Okay, so I will be your instructor for this subject, and my name is Engineer Peter A. Panorel. And by the way, this is our first lecture, and so we will not have mag-synchronous na klase because some of you have slow internet connection. Okay? So kung magpalong-palong na or maghinay na yung internet connection, naputol mo sa klase, di na mo kasabot dayon. So in our subject, so I will send you the video para continuous inyong pagpaminaw. Okay? And also you can join the server para kung namin mga questions dito na ninyo i-send. By the way, this is our textbook, Engineering Mechanics by R.C. Hebler. This is the 13th edition, no? And there are other textbooks also by Beer and Johnston, Vector Mechanics by Beer and Johnston. So pwede po ito ninyo gamitan as reference. By the way, the syllabus for this subject is kung i-post sa dito sa Discord server. Okay, so let's start with our class. So engineering mechanics. So the field of engineering mechanics, okay, is subdivided into rigid body mechanics and deformable body mechanics. Now, engineering mechanics deals with the condition of a body, the interaction between the forces and the corresponding motion of the body. Okay, so also fluid mechanics. So mo ni ang compose sa engineering mechanics. You have the rigid body mechanics. So kaning rigid body mechanics mao ni ang ENS 161 and ENS 162. Deformable body mechanics, ENS, I think ENS 163, and fluid mechanics, ENS 164. Now in statics, no, so rigid body mechanics is composed of statics and dynamics. So hopefully, no, na-learn na ninyo sa statics ang mga basic concepts like drawing the free body diagram, the reaction forces, no, determining the reaction forces, okay, applying the Newton's first law of motion. So dapat master na ninyo dito, especially ang pag drawing of free body diagram, very important. Okay, in studying dynamics, now in statics, mostly the problems are at rest, no, or kung nag-move man siya in constant velocity or there is no acceleration. Okay, so ang component nga nag-deal with the motion of the body is tackled in the dynamics part. So ang dynamics is also subdivided in two parts. You have the kinematics and kinetics. Now ang kinematics is concern ni mo diri is to determine the geometry of the motion. Geometry of the motion meaning the trajectory of the object. So tulo lang na siya, no? You have the position, you'll get the position of the body, the velocity, and the acceleration. Now in kinetics, 3 na yung part na we will deal with the forces. What are the forces that causes the motion? No? So that's it. Now in our lecture for today, we'll discuss some introductory concepts, the idea of kinematics, especially kaning tulo ka parameters, position, velocity, and acceleration. So sa kinematics, kanilang gid na tulo ka parameters ang atong ginakuha. Okay? And some examples. Okay, let's start with this quote. If I have seen a little farther, it is by standing on the shoulders of giants. So can you guess kinsang nag-state ani? No, kung na may idea, ang nag-state ani is Isaac Newton. Okay, probably the greatest scientist. Okay, so he was known for his three laws of motion, the law of universal gravitation. Okay, but according to him, kuha ra to nga na-discover to niya by standing on the shoulders of giants. So dili na ako jay na mga nag-contribute po, dili iya atanan ang idea ato, but it is also the culmination of the study from Galileo, Johannes Kepler. Okay, so itong mga findings nila gather ni Newton, but ang unique ni Newton, siya ang nag-formalize using mathematics, and na publish niya ang yung book which is called the Principia, one of the most influential na book sa classical mechanics. Okay, so what are the Newton's three laws of motion? By the way, ang prerequisite or requirement aning applying three laws of motion is you have a non-accelerating reference frame. Okay, no, meaning sama na siya pasabot ana. The non-accelerating reference frame kanang your origin, no, bantay ka. Later on we will show unsa ning reference frame. So ang meaning sa non-accelerating, meaning it is either steady or moving at constant velocity. So what is the first law of Newton's first law of motion? So the first law states that a particle originally at rest or moving in a straight line with constant velocity tends to remain in this state provided the particle is not subjected to an unbalanced force. Okay? Meaning if all the forces balances out, the object will remain at rest or moving with constant velocity. Okay? So but if there is an unbalanced force, meaning kung na-force na dili na balance mo nang dili siya in equilibrium. So that is why in ENS 161 you always try to find out whether the body is at rest, by summation of forces along x and along y. Kung equal to 0 ang all the forces in this direction, meaning your object is at rest or in equilibrium. Okay, let's move with the second law. Okay, the second law states that a particle acted upon by an unbalanced force experiences. Okay, so mo na ni, no? What if there is an unbalanced force? So the second law states that if you have unbalanced force F, the the particle will experience an acceleration A that has the same direction as the force and magnitude that is directly proportional to the force. Okay? So, ngayon dere nga the particle will experience an acceleration that is directly proportional sa imong force. Okay? Kung dako imong force, dako imong acceleration, and it is denoted by this equation: F is equal to m times acceleration. Okay. Third law states that the mutual forces of action and reaction between two particles are equal, opposite, and collinear. Meaning, if you apply a force in this direction, the reaction force is equal and opposite. Okay. Let's move forward with kinematic. Kinematic relationships are used to help us determine the trajectory of a golf ball, the orbital speed of a satellite, and an acceleration during acrobatic flying. Okay, so meaning we are concerned with the trajectory or the geometry of the motion. Okay, so why is it important? No, knowing the trajectory, especially in designing machines, kung makabalo ka sa motion sa imong parts sa imong machine, then importante na siya para mahibalan mo ang interaction kung di ba siya mabangga sa other parts. So that is why you need to know the geometry sa mga parts sa imong gi-design. Okay. So kinematics is the study of the geometry of motion. So relate ani niya is displacement, velocity, acceleration. So kaning tulo parameters, and time without reference to the cause of motion. So mo ni ang keyword, without reference to the cause of motion. We do not deal, no? Pila ang amount of force na gi-exert para mag-produce aning motion. So wala pa nato nagi-consider. Later on, we will consider that in the kinetics na part. Okay. Now, kani siyang fighter plane. Ang forces nga nag-involve ani is you have the drag, thrust, ang kaning thrust na produce niya sa mga engine. So mo na yung nag-drive sa mga plane. And lift, kulang nag-isa, no? Kulang nag-isa ka forces, which is the weight, no? Weight. Ang lift is produced by the wing, no? Kanina yung wing sa ang plane. Okay, kinetics is the study of the relations existing between the forces acting on a body, the mass of the body, and the motion of the body. Kinetics is used to predict the motion caused by given forces, or to determine the forces required to produce a given motion. So, mo ni siyang importance sa kinetics, no? To determine the forces required to produce a given motion. Say for example, na kay parts sa imong machine nga gusto nimo moabot diri. So how much is the force na kinahanglan nimo i-exert para makaabot sa diri nga part? Okay. Now we will move forward with kinematics, no? The first part of our topic, which is kinematics. Now, ang kinematics, no, sa motion, there are three types of motion, no? You have the rectilinear motion, you have the curvilinear motion, and also the combination aning duha, no? Rectilinear motion meaning the particle moves in a straight line, and the curvilinear, from the word itself, curve, so ang imuang object moves or produce moves in a curved path, no? Tumaw na siya. Okay. So sa may mga example na ng rectilinear motion, ning motion sa imo ang train, no? Motion sa imong car, no? Kanang kung straight lang ang yang dagan. Okay. So in kinematics, we are concerned with these three parameters: position, velocity, and acceleration. So we will define say meaning aning tulo ka parameters. Okay. So first is the position. So looking this diagram, you have this point O, origin. So ano siyang origin? Ano siyang katong sa gitawag na to kaganihan nga non-accelerating reference frame. So importante ning origin, kaya without aning origin wala kay sinugdanan, no? Origin, or you don't have a datum. So importante ni siya. Okay, so ang position is defined as the distance from the origin to the particle. Okay? So ang first part sa dynamics is we are modeling mga big objects as particle. Ano man? Like ang Earth, pwede nimo na siya ma-model as a particle. No? Although ang Earth is dako, diba? Dako kayo. But kung i-compare niyo siya sa iyang orbital na path, no? Ma-model niyo siya as a particle. So that is why the first part sa ato ang lecture or sa ato ang subject is determining the motion of a particle. No, of a particle na naman kay ma-relate man nimo siya sa even sa dagko nga butang. Like even human, model na nimo as a particle, no? Depende sa imo ang reference. Okay. So ang position is can be positive, can be negative. So this is the distance from the origin to the particle, kaning denoted by S. So nasa direction. So this is a vector quantity, no? Vector quantity has magnitude and direction. Magnitude meaning 5 meters, 5 kilometers. Direction, so kung nasa left sa origin, negative, nasa right, positive. So displacement. Now the displacement denoted by delta S is the change in its position. The change meaning if this is point 1, this is point 2, ang imong object started at point 1, then at certain time naabot sa diri. So ang displacement ana niya is imong i-minus ang final position minus initial. So you have delta S. Again, this is a vector quantity. Okay. Okay, so na-define na nato ang position. Next is the average velocity. The average velocity is just the displacement over the time interval. So it's equal to delta S over delta T. You have also instantaneous velocity. So ang instantaneous velocity is the limit as delta T approaches 0 of this value, or this is just ds over dt. Okay, so unsay difference aning average velocity and instantaneous velocity? Say for example, na kay particle A at this position, and then there's certain time naabot sa diri at point B. So ang average velocity, kung mayroon kag average velocity, imo ning kuhaon, di ba? Ang displacement ani is B minus A. So kani over kung pila tong time na time interval niya before siya naabot sa B. So mo na mong average velocity, meaning nag-move ng A ni mo dere, di ba? Pwede man na ang pag-move ani kay kung sample tawo ni nagdagan. Pwede mo ka una kusog kag dagan, ikapoy na ka hinay na kag dagan. Hinay na. No, then pili mo na nga gusto na po ka kusog mo dagan. Kung i-average ito nimo, tanan, mo na ni siya average velocity. So ang pagkuha, get the displacement and then divided by the time interval. Now, when we talk about instantaneous velocity, mo na to siya. Kung gusto nimo may balan, unsa ang velocity during a point or during a point. Di ba kay change man na di mo na sa constant change man na siya. No? So kani mo gamiton. So ano mo pagkuha na manay equation. Ang kaning S, di ba? S is the position. Kung naman na sa equation is S is equal to a function of time. Function of time. I-differentiate to nimo with respect to t time, you'll get the instantaneous velocity. Okay, next. You have also the average speed. So, unsa ni siya? Average speed is a scalar quantity. Scalar quantity, so wala sa direction, magnitude lang ni siya. So, this is the total distance traveled over the time interval or the elapsed time. Timanan nino total distance traveled. So, ang total distance traveled, say for example, kaning example, you have a particle at origin and then move siya, no? Ano siya, dagan sa 3 paana taman sa 4. Dayon may balik na po siya taman diri. So kung tagwa ni siya, so negative 2 ni negative 2. Okay, the question is calculate the average velocity and the average speed. Again, the average velocity is displacement over the time interval, which is 1 second. Okay. So ang displacement is final position minus initial. So negative 2 minus 0 is negative 2 meters. Divided by 1 second is negative 2 meters per second. However, the average speed is total distance traveled over delta t. So, ang total distance traveled niya is 1, 2, 3, 4, balik 5, 6, 7, 8, 9, 10. No? So, you have 10 meter over 1 second. So, muna siya. This is the average speed. So, sayon na siya, no? Okay, let's move forward with the average acceleration. Again, the average acceleration is just the difference of the final velocity minus the initial velocity over delta t. And just like the instantaneous velocity, na po yung instantaneous acceleration. You differentiate the velocity with respect to time. Okay, so if you want to relate the acceleration with the position, so sa buhaton nimo kani nga v dire imong substitute ni mo ni dire. So mahitabuan ni second derivative of s, no? And then if you want to relate acceleration and velocity or eliminate delta t, so ang buhaton nimo na kaning delta t ay kaning dt dire, substitute nimo dire, and then you will get this equation. So sayo naman na sila, just practice, no, deriving this one. Okay, let's proceed with the kinematic equations for constant acceleration, no? So what will happen if ang imong A is constant, meaning just like gravity, ang gravity is a constant acceleration, negative 9.81 meters per second squared. Okay, so A. Okay, so this is the first kinematic equation for, remember, for constant acceleration. Dili mo na siya gamiton kung dili constant ang acceleration. Okay, so buhaton ni man is just differentiate get the integral of dv and kanidri a dt. But since constant man pwede naman ipagawas. No, so always remember na dili nimo makuha ang integral ani kung ang a nimo dili function of time. So duha ra na siya. Kani siya dapat function of time or constant. Kana lang duha ka condition para ma-integrate nimo ni, otherwise di nimo ni makuha ang value ani. Okay, so kani siya is v minus vo, i-transpose dito sa pikas mo ni. Second, position as a function of time. So v is equal to ds over dt, assuming that initial is equal to so when t equals 0. So wato ni man again ahaman ni gikan ni siya dire, no? Gikan ni siya dire. But kaning v mo ni ang v dire. So kaning value gi substitute dire. Mo din ang nakuha. Anyway, we will derive this one and we will have an example. Velocity as a function of position. So gikan na ning equation. Again, integrate and you will get this equation. So this is our first example, and you have a car that is moving in a straight line. Okay, so the velocity is defined by this equation. V is equal to 3t squared plus 2t, and the unit is feet per second, where t is in seconds, and so determine the position. So what is asked is we need to determine the s and the acceleration at t is equal to 3 seconds. Okay, so how are we going to get the position and acceleration? So can we apply the kinematic equations for constant acceleration? Okay, pwede ba nato ma-apply? Direct? So siguro sa problem of students is i-apply din ang kinematic equations without first determining kung pwede ba sa i-apply. So kung saan pag-determine na is kung mao ni ang v nimo 3t squared plus 2t, ang condition is dapat ang a, ang acceleration must be constant. So itong try, di ba? A is dv over dt. You have 6t plus 2. So ang question is constant ba ni? Since na may variable, dili gini constant. Not constant. So dili nato magamit tong equation nga v is equal to vo plus 8t. Ito magamit mga kinematic equations. Ang bato na to ani is kanitong gamiton. Oh, by the way, na naman so itong buhaton na is multiply na to ng 3 dire. So you have 6 times 3 plus 2 is equal to 20. Ang unit is feet per second squared. Or kung English, meter per second squared. Okay, unit sa acceleration. Unit sa velocity is m per s, feet per s. So, nakuha na to. Ang first nga ipangita, acceleration. Okay. Next, how will we get the S? Since given man velocity, diba? S is ano? Velocity is ds over dt. Therefore, ds is, or integral ani is v dt from 0 to s, from 0 to 3. Okay, so this becomes s is equal to, ang v ni mo imoning isulod dali 3 t squared plus 2t from 0 to 3. So, the answer you have t cubed plus t squared from 0 to 3. Tama? So, ang answer is 27 plus 4 is equal to 7 ba? 3 times plus 9 ay. Plus 9. Answer is 36 feet. Okay, so that's it. The next example is we have a rocket that travels upward at 75 meters per second. And when it is 40 meters from the ground, its engine fails. So determine the maximum height S sub b reached by the rocket and its speed just before it hits the ground. Okay, so there are two parameters, no? Atong kuhawan na nga problem. So while in motion, the rocket is subjected to a constant downward acceleration of 9.81 meters per second squared due to gravity. Neglect the effect of air resistance. Okay. So first, let us draw the representation of this problem. Okay. So this is the ground. You have a rocket. Okay. So let's just model this rocket as a particle. Okay. So you have a rocket, and then it travels at 75 meters per second. Okay, so given the rate, when it is 40 meters from the ground, so if this is 40 meters, okay, so pag abot sa rocket dere, at 40 meters, the engine fails. Okay. So, napalo ang engine na ni. But, since nag-travel naman niya at 75 meters per second, mapadayon pa ni sa lupad, no? So, posible, mulupad ni siya, ano sa man ni mahunong? So, mulupad ni siya until ma-reach niya ning the maximum height, which is what you denoted as S sub b. Okay, no? Lupad na siya na. Now, dire siya, mahunong ni siya sa S sub b when the velocity is 0. Of course, diba? Kung naka 75 dire, siyempre, mahunong nila siya, taman. Wala na siya velocity. And then, kung 0 ng velocity, hulog na balik dire. So, ang ipangutana is maximum height. So what is S sub B and what is, okay, so kung point A ni dire, point B, this is point C. So unsa ko ng velocity before siya mo-hit dire, so B sub C. Okay, so first unsa ang given ani? Given kag VA, no, VA which is 75 meter per second. Given ka og acceleration which is negative 9.81 meters per second squared. And then given ka aning 40 meters. Okay? Okay, so unsa ang equation na gamito nato ani? Since S sub B atong pangitaon, so given kag velocity, gamito nato tong kinematic equation that would relate velocity and position. Okay? So unsa to siya? You have velocity final squared is equal to plus 2, since given man na constant ang acceleration, no? Constant acceleration. So kani itong gamiton, no? Remember, gamiton na nato ni if the acceleration is constant. S sub F minus S sub O. Okay, or in this case, pwede nato ning apply dire sa kung initial nato ning A then B. So you have the velocity B squared is equal to velocity A squared minus 2. Anong minus kay kani negative 9.81 S sub B minus S sub A. Okay. Now, ang S sub A na to, kaning 40. Mo man yung location sa point A. Okay, so based na rin, makuha na nato ang S sub B. Okay, so by the way, velocity velocity V there is 0. 0 ni. 0 is equal to 75 squared minus 2 times 9.81 S sub B minus 40. Compute na to ni, ang answer ani is S sub B is 327 meters. Okay. Okay. The next question is, what is velocity C? Okay, so gikan dire, diba, 0 man ni dire, kay mo man ni ang pinaka paglupad sa imong rocket, siyempre na, gikan dire, taman sa wala na siya velocity, mahulog sa balik. No, paghulog ani balik, siyempre dili ni 0 ang VC, ano man, just before it hits man eh. Siyempre, itong paghulog ka na, pagbunda ka na, after pila ka minutes, pa naman 0. Pero the moment na pag-igo pa na dire, dili pa na 0. So, applyan na to na dire from point B to C. No, from B to C. So, you have kanina gyapon nga equation. You have BC squared is equal to velocity squared minus 2 9.81 S sub C. Ang S sub C ni mo, since diri mo ang reference point, 0 minus S sub B. S sub B which is 3 to 7. Okay. And then, kani, 0 man eh. Therefore, velocity C is 80.1. unit sa velocity, meter per second. Of course, since this is a vector quantity, butangan na nimo og direction going downward. Okay, so that's it. No, you just have to remember na gamiton nimo ning equation when constant ang acceleration.